All right, so we're going to continue with our second installment, this bit on installment loans. So these are a different kind of loan that you can take out. Like I said, these are like mortgages or car financing or student loans. So student loans definitely fall under installment loans. So these are more intentional than credit card debt. Apologies for any noise that you might be hearing in the background here. We've got some things going on in the house today. But, oh well. So, more intentional than credit card debt. Here, the borrower pays back the loan in equal, regularly spaced installments. Equal, regularly spaced installment. Okay, so this is what is known. This is known as amortization. And what is amortization by definition? So, amortization is the process of paying off a loan by making regular installment payments. Paying with monthly installment payments. Okay, so that's amortization. That's our keyword for this lecture. Good. So this allows consumers to purchase bigger items. Or to finance. This is what they say. To finance big ticket purchases. Good. So we're going to have a formula, just like we had for other ones. This amortization formula, by which we figure out what your monthly payments should be, is quite closely related to the compound interest formula, because these installment loans almost always are compound interest, and so it's a combination. So since installment loans are almost always using compound interest, as opposed to the simple interest that we were using for in the last lecture on credit card debt. Installment loans almost always use compound interest. We find a formula for amortization. By combining the compound interest formula, I'll put in parentheses the monthly compound interest formula, and geometric sums, like I made a lecture about. Okay, so we combine these two things and we get our amortization formula. So I'll write it in letters first, and then underneath I'll tell you what the letters mean. I'll say it out loud as I write it. So M is going to be your monthly payment amount. The amount that you pay monthly is going to be P, capital P is still your principal. Yes, the initial amount that you take out in the loan. And then up on top here, we're going to have little p, and little p is your periodic interest rate, like we calculated in the last lecture. 1 plus p. That's oftentimes your annual interest rate divided by 12 if it's going to be a monthly thing. But we're making this more general. Raised to the power of t, where capital T is the number of payments that you'll make. And all of that over 1 plus p to the t minus 1. Okay, so that's the big formula for today. All right, so let's use this and do some calculations. That'll be fun. So, so let me write where M is the monthly payment. M is the monthly payment. P is the principal. Little p is going to be your periodic interest rate. So that's going to be like R over 12 if monthly. Interest. If interest compounded monthly. Where remember little r was our APR expressed as a decimal. And T is the number of monthly installments. Notice that all of this is being done in months. That's really the most common scenario. You won't, almost all installment loans are paid off monthly. Yes. Good. Monthly installment. Note, we installment loans are almost always monthly payments. So we use months. Good. Okay. Instead of like the 31 days for the last one, because we were doing more specific calculations with those credit card debts. Good. So let's do some examples like before. So let's do our first example is going to be on a car loan. This is a pretty common example of an installment loan. So to finance let's say $23,995, you find a car. A new car. $23,995 car. Let's say that includes all of your taxes and fees. Like licensing fees and all of that. We're not going to take that into account. And then we have to, so say that when you buy the car, they give you two options for how to finance it. The first option they give you is like 1.2% APR for 60 months. And so you can pay this $23,995 off over 60 monthly payments with a 1.2% annual interest rate. The second option they give you is that they can take $2,000 off of the price of the car, now manufacturer's rebate they call it, and then you can pay a higher APR of 6.48% for 60 months. And you want to decide what should you do. Obviously the one of them has a much higher APR, but it also is taking percentages out of a smaller sum. So, choice of two options for financing. The first option is going to be a $2,000 manufacturer rebate, then 6.48% APR for 60 months. And option 2 is going to be 1.2 simple 1.2% APR for 60 months. Let's compare. Okay, good. So if we're going to do number 1, so let's copy it. Copy. And I'll paste it here. So this is our first one. I'll make it a little bigger. Good. All right. So now our principal, our principal P is going to be the sum of money we need to borrow for the car, which in this case is the price of the car minus the $2,000 manufacturer rebate. So that's going to be $23,995 minus the $2,000 manufacturer rebate. It's going to be $21,995. Okay. And so now we know, let's do our APR as decimal. R is going to be 0.0648, right? So that means that P, little p, is going to be R divided by 12. And I did this calculation already. This is 0.0054. So that's going to be our periodic interest rate. If R is our annual interest rate, P is our monthly interest rate. But the word periodic just means that we're not being specific about whether it's monthly or annually. It's specific to it's only specific to the period that we're talking about right now, which is 1 month. Good. And T, the number of monthly payments, is going to be 60. Okay, so let's just plug into our formula. Remember, here's our formula here. Copy. So, paste. So, yes. And I'll delete this funny thing. Good. So, if this is our monthly payment, let's plug on in. So M is going to be our principal, $21,995, multiplied by P, 0.0054, times 1 plus 0.0054, so that's 1.0054, raised to 60th power, because that's how many times you pay. Divide all of that by 1.0054 to the 60th minus 1, and plug all of that into your calculator. I don't want to do it because I've already done it. We're going to get $430.15. Now, if this is mysterious where these formulas come from, I recommend you go back and look at rewatch lectures on sections 10.2 and 10.3, where we really went into detail about how to calculate those simple interest formulas and compound interest formulas. And then if you watch the geometric sums video, you should be able to arrive at this amortization formula on your own, even though I won't expect you to be able to do that generally. Good. Of course, now that we don't have more exams, it's not like it. Yeah. One way or another. They were open notes before. It would have still been. Good. So that's our first option. And then if I Okay. And so then let's do our second option. Now our second option is a 1.2% APR for 60 months. So let's say good. Versus 1.2% APR for. Okay, so now let's do the same calculations again. So now our principal is going to be normal, so that's 23,995 like before. Our APR is now 0.012, which means that P, which is going to be R divided by 12, is going to be, well, 0.012 divided by 12. That should give us 0.1 divided by 10.001. I think so. Multiply 0.001 by 12 and you get 0.012. Yeah, good. Good. So that's going to be our periodic interest rate there. What other things do we need to know? We need to know T is still going to be 60. Okay, and I think that's all we need to plug into our formula. So 2 gives M equal to 23,995 times 0.001 times 1.001 to the 60 divided by 1.001 to the 60 minus 1. And so all of that comes out to, I'll do this one on the calculator because I actually didn't do this one out before. Okay, so what do we need? 0.001. Let's do our exponents first. 0.001, because this, I know this is a bad calculator, so it's a good one for you to watch me try with. 1.001 to the 60. Good. And then I'm going to multiply that. I'm going to hit equals just in case it doesn't know order of operations. I'm going to multiply that by 0.0001, our periodic interest rate, equals. Okay, so now I'm going to have that on the top of my fraction. And on the bottom of my fraction, I'm going to have 1.001 to the 60th minus 1. So now I'm going to test it. Divided by, and I'm going to open parentheses, 1.001 to the 60th. Let's see if it knows what's up. Okay, let's try that. And then, oh, I messed up. Let's see. Times 1.001. Here. Times 1.001 to the 60th. Sorry. Get back to there. Now I messed up that first. So what I wanted to divide it by was, maybe I'll do 2 parentheses. 1.001 to the 60th. Close parentheses. Minus 1. Close parentheses. Okay, and now I'm going to multiply that by the principal, 23,995, and good. So $412.23, let's say. $412.23 in monthly payments. So which one should you do? Well, I guess you should actually go for the original one, because then you'll be paying like $17 less per month, I guess. So choose the standard 2 for lower monthly payments. And an important thing when you think about lower monthly payments, it's not just lower monthly payments, but lower monthly payments over the same term, right? Vocabulary from earlier in the chapter. the term of the loan, the life of the loan, how long you have to pay it off. Okay, good. Let's move on to a second example, which is going to be on mortgages. So, example 2, I'll do it on a separate page. Example 2, mortgages. So, in this one, you're going to, imagine that you're a homeowner and you get an offer in the mail to refinance your mortgage. I'm sure you've heard of this kind of thing. Imagine you are a homeowner paying a mortgage. I'll be specific. A 30-year mortgage. On a $180,000 house with 3.9%. Oh no, sorry, 4.8% APR. Okay, so this is the setup. You bought a $180,000 house. You got a 30-year mortgage on it with a 4.8% annual interest rate. Good. Compounded monthly, because mortgage loans are always compounded monthly. Compounded monthly. Like all mortgage loans. Okay, that's the setup. Now you receive an offer in the mail. You receive an offer in the mail. I before E, except after C. And this offer says this. They offer you a 3.9% APR, lower than yours, on a 30-year mortgage. Okay. So same term as your mortgage. In addition, though, so before you just switch right off the bat, because of course, like if there was no other added conditions to this, then you would want to just switch, because this is gonna, like, they'll take off the monthly payments that you've already made on your other one, and your principal for the new loan that you took out would be on the same sum. Okay. An APR, 3.9% APR on a 30-year mortgage. In addition, there are loan origination costs, they call them. And what these are like basically just added costs. So that consists of $1,500 just for the closing cost of the loan, plus 1 point. And this is some loan jargon. This is 1% of the original loan. Ugh. And what we want to know is, should you switch? Well, of course, these are, we couldn't say right off the bat. I mean, if you could do all of this math in your head, that would be quite incredible, but we're gonna work it all out. Okay, so we're gonna divide this problem, as we do in math. We take a big problem and we split it up into smaller problems. So the first calculation, so step 1. What are you paying currently? So let's do those calculations, because I told you all the details of the loan, but I didn't actually tell you what your monthly payments were. So currently, your monthly payments is your $180,000 principal multiplied by the periodic interest rate. Oh, don't know what that is. Multiplied by 0.004. So 0.004 is your, here, I'm going to move this over here. This is your periodic interest rate. And that, how did we find that? That's R over 12, which is you're currently paying 4.8% APR. So that's 0.048 divided by 12. So you know. Okay, and then we're multiplying that by 1.004 raised to the number of times you're paying. So raised to the 360, because that's 12 months. That's 12 months in a year times 30 years. So that's 30 years times 12 months for a year. Okay, and we're dividing all of that by 1.004 to that same number, 360 minus 1. Okay, so we're going to do all that out, and I'm not going to go back to the calculator because it takes up time and wastes it. This turns out to be $944.40 per month. Okay, so that's the first step. Know what you're paying right now, $944 per month. 2, we want to see, so I forgot to add this condition, which is that you've been paying for 30 months already. So let me add that here. After 30 monthly payments, comma, you receive an offer in the mail. Okay, so now we want to find remaining balance after your 30 payments. So what is this going to be? This is going to be a... All right. We can solve amortization formula for P. So let's say that your month, so now we, again, remember we have M equal to P times P times 1 plus little p to the T over 1 plus little p to the T minus 1. And so now we're going to have 944. So notice that if we wanted to just get P, but we knew M, we could divide M by this whole big thing that is sitting on the next to P here. So now 944.40 is equal to P times the same old thing. So we had 0.004, 1.004 to the 3, not 460 now. We now have 330 months left, right? 330. So now this is the number of months left to pay after your 30 months. Okay, we're going to divide all of that by 1.004 to the 330 minus 1. And so if we divide both sides of the equation by both sides of the equation by that thing, what we find is when you enter in your calculator, get p is 9. Well, I'll write this out. Remember, dividing by a fraction, you can flip the fraction. So that's 0.04 to the 330 minus 1 over 0.004 times 1.004 to 330. Okay, and I already did this out again, and what we get is $172,863.07. So this is how much you have left to pay. So now we have a few more things left to do. So now we know step 1, what you're currently paying. We know step 2, how much you have remaining to pay, because your monthly payments are actually changing now, right? Good. Okay. And so the third thing we need to know is so step 3. It's going to be, what are the what would you be paying if you were going to switch? If you switched. And we'll do the same old calculations. So now your principal, if you were going to switch, is the amount that you still have left to pay. You wouldn't like pay again the amount that you've already paid. Now your principal is 172,863.07. Our new APR as decimal R is now 3.9%, goes to 0.039. Our periodic interest rate, which is our annual interest rate of 3.9% divided by 12 months, is going to give us 0.00325. And the number of payments that you have left to make is 330. You know, your 360 payments minus 30. Okay. Don't pay same payments. Again, if you switch. Okay. So let's do that. What would be your monthly payments? So now, let's call it M prime, being the other one, is going to be 1. I want to move this up. 172,863.07 multiplied by 0.00325, our periodic interest rate, times 1.00325 raised to the 330th divided by 1.00325 raised to the 330th minus 1. And again, did all this out. Don't feel like doing it again in the calculator. This gives us $854.78. Okay, so this is actually a better deal. Before, so we compare. Originally, you were paying $944.40, and this one you pay $854.78. So switching would save you $944.40 minus $854.78 is equal to $89.62. $89.62 per month. But wait, remember we had those added costs. Step 4 is going to be finding out what you should do. Pay up front. Up front, you pay, what was it? $1,500 plus 1%, so that's 0.01 of your original loan cost was $180,000. And so what this gives you is 1,500 plus, move the decimal point over to 1,800. So this gives us $3,300 of upfront costs. So how long would that take you to pay off if you're saving $87.62 per month? This will take, well, how long will you pay this off in? We just do some basic division. 3,300 divided by 87.62. And what we get is, let me just enter that in. Divided by 89.62. And give us 36.822 something. So it's going to take about 36 months. So if you plan to keep on paying that mortgage for the next 36 months or 3 years out of a 30-year mortgage, then I guess it's worth it to switch, because as soon as you pass through those 36 months, you'll start saving money. I mean, you'll pay that $3,300 up front, and then you'll save $87.62 per month, and after 3 years, you'll actually start saving money if you take this offer in the mail. So if you plan to stay in the house, of course, now we take these things literally. I don't mean literally stay in the house. Keep on owning the house for 3 or more years, then yes, it is worth switching. For once, a mail offer is a good one. Good. So that's kind of the consensus. That's the end. We've now done one example for car loans, one example for mortgages. These are the two biggest kinds of installment loans, and yeah, I hope that was helpful. So takeaways: credit card debt, installment loans. Be careful of debt.